Okay, so now let's try this one. We've got an integration by parts. And in this case, we're going to have to do, there's two things that are going to go on. We're going to evaluate a definite integral, which is something a little bit different than we've done before. And we're probably going to have to go through and repeat the process that we've used more than once in order to do this. Okay, so in order to evaluate this definite integral, we have to know what's going to happen with the antiderivative. So let's go to the antiderivative first. And we're going to evaluate x squared times e to the x dx. All right, so what can we say about it? Well, in this case, it looks like our good substitution right here is going to make u equal to x squared. This kind of looks like one example that we did earlier. So that dv is going to be equal to e to the x dx. Remember, our goal here was to rewrite one of these so that we don't make things more complex, we simplify them. All right, so we're going to make du equal to 2x dx. Of course, that means that v is just going to simply be e to the x. All right, so let's rewrite now. We're going to get our integral. It's going to look like this. It's going to be u times v. So we're going to get x squared times e to the x, and we're going to subtract from that 2 times the integral of x times e to the x dx. And this looks kind of familiar, right? We actually did something like this one before. And if you recall, what we had to do is we had to evaluate this piece using an integration by parts. So we're going to do an integration by parts a second time where we're going to let u equal x, which means that we're going to get a du equal to dx. And in this example earlier, we had let e to the x be dv, right? So dv was equal to e to the x dx, and that implied that v was going to be equal to just plain old e to the x. And so now we're going to get this new expression, kind of interesting, that's going to be equal to x squared times e to the x like we had before minus 2, and this time I'll put this in purple so we can keep track of the new u, x times e to the x minus the integral of du, right? So it's going to be v du, so that's going to be the integral of v e to the x du, which is dx, right? And now we don't need to do another integration by parts because now we're going to end up with this brand new expression. So we're going to get x squared e to the x minus 2 times the quantity x times e to the x minus e to the x, and we would say plus c normally, right? But now we remember that we're evaluating this guy from 0 to 1. So let me simplify this a little bit because it'll be a little bit nicer to work with if we do. We're going to get x squared times e to the x minus 2x times e to the x, this time plus 2 times e to the x, and we're going to evaluate this from 0 to 1. Let's make it a little bit easier. Let's come on over here. Give ourselves a little bit of room. E to the x then is going to be multiplied by the quantity x squared minus 2x plus 2. Only this time we're going to evaluate that from 0 to 1. So let's see what's going to happen. At x equals 1, we're going to get e to the first times, let's see, 1 squared minus 2 times 1 plus 2, well, that's just going to be 1, minus e to the 0 times 0 squared minus 2 times 0 plus 2, so that's going to be 2. And so if we work that out, that's e times 1. E to the first is just itself. E to the 0 is 1 times 2, so minus 2. So this is our evaluated integral. That's our definite integral. Okay, good luck with your work.